All right, guys. Good to see you again. We're going to continue on with Chapter 8, Section 5, Multiplying and Dividing Radical Expressions. We're going to focus on one more example with this part here. And the bulk of our talk today, though, will be on rationalizing denominators with binomials involving radicals. So the reason I want to do one more example here, didn't put it in yesterday's or the prior section's video, but we want to talk about simplifying when we have different indices. Okay. So here we have the cube root of 15/32. So again, we're going to break that into two parts, the cube root of 15 and the cube root of 32. Now, we can't do anything about the cube root of 15, but we can do something about the cube root of 32, because this cube root of 32 can be broken up into, and I would prefer to write this as the cube root, oops, I don't want that. The cube root of 15 over the cube root of 2 cubed times the cube root of 4, or 2 squared. So that's what 8 is. 2 cubed is 8. So now, when we go to simplify that, the 2 is out of the radical. So now we've got the cube root of 15 over the 2 times the cube root of 4. So now we can multiply both the numerator and the denominator times the cube root of 2. What's that going to do? Well, you're going to end up with 2 squared times 2, the cube root of 2, and you're going to multiply that through and end up with the cube root of 30 over 2 times the cube root of 8. Okay, so they left that piece out. So this ought to be 2 cubed root of 8. Cube root of 8 is again equal to 2. So you end up with the cube root of 30 over 4. Again, we're going to end up with the 4th root of w squared in the denominator here. You'll notice you need to have this in the problem, because if it's 0, it's moot. It doesn't matter what you put in there. It's going to be 0, or it's going to be undefined. So the 4th root of 6y over the 4th root of w squared. So they're going to want you're going to want to multiply and get to w to the 4th. So you're going to multiply by w squared in the denominator. So in doing that, I end up with the 4th root of w to the 4th, which is w. So you multiply in through the radical there on the denominator here. And so we end up with 6yw squared, and then we want the 4th root of that. Okay, let's start talking about rationalizing denominators with binomials involving radicals. So, to follow along here, to rationalize a denominator that contains a binomial expression, one that contains exactly 2 terms involving radicals, such as 3 over 1 plus the square root of 2, we use a conjugate. So conjugate, basically what it does is it eliminates the it's like multiplying the difference of 2 squares. You end up with 2 terms that you can actually add together here. So the conjugate of 1 plus the square root of 2 is 1 minus the square root of 2. And so no matter what this sign is, it's got to be opposite to get the conjugate. So the rule, whenever a radical expression has a sum or difference with square root radicals in the denominator, rationalize the denominator by multiplying both the numerator and the denominator by the conjugate of the denominator. So let's talk about this. So we're going to get rid of, or we're going to simplify 7 over the square root of 2 plus the square root of 13. So the conjugate of the square root of 2 plus the square root of 13 is the square root of 2 minus the square root of 13. So now when we multiply that through, you'll see that it becomes 7 times the quantity square root of 2 minus square root of 13 over 2 minus 13. So this becomes 7 square root of 2 minus square root of 13 over negative 11. If you wanted to take that further, you always could. And this could be 7 square root of 2 minus 7 square root of 13 over negative 11. Okay? Either one of those I'd accept. Oh, excuse me. No, I won't accept that. I almost went on here. I can't accept that one because it's got to be 7 square root of 13. That I would accept. Oh, and look at that. Okay. All right. Now, square root of 3 plus the square root of 5 over the square root of 2 minus square root of 7. So there's two parts to this. Again, we've got to come up with the conjugate. So you're going to end up with this, okay? So over here, we could use FOIL to multiply these two together. So in the next step, you'll see this becomes square root of 6 plus square root of 21 plus square root of 10 plus square root of 35 all over 2 minus 7. And we would simplify 2 minus 7 is negative 5. Okay, so for our next, we've got 2 over the square root of k plus the square root of z, where k does not equal z, and k is greater than 0, and z is greater than 0. So, again, multiplying by the conjugate would be the square root of k minus the square root of z. So we're going to multiply through. And you have 2 times the quantity k minus the square root of k minus square root of z over k minus z.
That's all, folks.